Dear students, in this program, we'll be discussing single linked list, how to uh, create single linked list, and how to perform stack operations like push and pop. This is a problem statement. Develop a menu-driven program in C for the following operations on single linked list of student data with the following fields. The fields are USN, name, program, semester, and phone number. So you have to create a single linked list with the help of front insertion, creating n number of students nodes. Display status of single linked list. Also display the count of number of nodes in the list. To perform insertion deletion at end. To perform insertion delete at other end. With this, no, you have to demonstrate the stack operations also. The program requires both input operations or output operations, which involves scanf and printf statement. So stdio.h is required. We'll be allocating the memory with the help of either malloc or calloc, and even will be stopping the program with the help of exit library. For that, stdlib is required. We'll assume that we'll be having only 4 nodes in the linked list. At the most, we'll be having 4 nodes in the linked list just to uh, demonstrate stack operation. When the linked list consisting 4 nodes, and when you're trying to add one more nodes, it should give overflow error. For that purpose, we'll be assuming 4 nodes in the linked list. So initially we are setting the count to 0. So here we need to have the linked list. Correct. The linked list is created with the help of a kind of structure, and one of the members should be self-referencing node. We'll take example like it has got two fields mainly. One is the data field, this is the data field, and other one is the address field, or also called link field. This is the link field. This particular member is a special member which is also called self-referencing node. That means it holds the address of another node, which holds the address of another node, and that another node is of same type. That's the meaning. So this is a special member, a special type of member of that structure, which is called self-referencing node, which holds the address of another node which is of same type. In our question, we are having these many fields like USN field, name field, the program or the branch, semester, and the phone number. This data field is divided into these pieces, parts: the USN field, name field, branch field, semester field, and phone number. Here also same thing: USN, name, branch, phone number, and semester. Okay. In this, the semester field is numeric type. Semester 1, 2, 3 like that. This is the numeric field. The rest of the things are all characters or the string. That is why we have declared here USN is of size 10, name is of size 30, branch is of size 5, phone number is of size 10, and semester field is numerical field, that is integer. And a self-refreshing node. The field name is next. You can use any variable. Here in this example program, we have used the member name as next. Suppose the variable that is used to refer this is p. P of next is p of next. The pronounce is like p of next. P of next is this particular thing. If this is q1 and this is p, then p of next is pointing to q1. So p of next is also equal to q1. That is the meaning of pointing with the help of single linked list. These are all the members required, and we'll create one alias name called node, which is of type this customized structure called student that can be created with the help of type def struct student node. So the first step is to grab the free memory locations. That can be done with the help of ML functions. So wherever you are asked to create a node like insertion at front end or the rear end, we need to have one raw node. That can be done with the help of by calling the function getNode. The after obtaining a node, it should return that node. So return address should be that address of the node, that is a pointer node star get node. No need to pass any parameter. The first is to allocate the memory location. For example, this is a node. We need to create a particular node. In order to create the node, you should have that much of memory locations. Size of USN, size of name, size of branch, size of SEM, size of phone number, and the address. All together, that much of memory location is required. So for human being, it is difficult to count all the things. So we can do with the help of size of function, size of that node. So you can use MLOP function or CLOP function. MLOP will retain the garbage value, CLOP will clears that value. So here in this case, MLOP is used. So that should hold only the structure. Though it is a raw, it should hold the type node. So that is referred with the variable new node. For example, if this is created and the new node is created, I'll be taking USN as U1, name as N1, branch as B1, okay, SEM as say 5, and phone number is say P1, and this is a self-refreshing node. So this name is new node. When you create that with the help of MLOC, it should return a node. That node variable is new node. That is the meaning. New node. Okay. Now, user has to enter the value for USN name, branch, semester, and phone number. That can be done with the help of scanf statement. The first field is for the string of type string, second is string, third is string, fourth is numeric, fifth is string. So out of these five fields, first three fields are string, so that can be done with the help of percentage %c, and this is numeric percentage %d, and this is again string. That can be stored with the help of variable that new node and member name. New node of USN is this value entered U1. New node of name, new node of branch, see the difference. For primitive type of data, same is a primitive type of data, that is integer. So we have to use ampersand. For all the other things, no, not required. After doing so, the next field, this is set to null. As we don't have any other address to store, you set that to null. After creating node, one node is incremented. So the count of number of nodes is incremented by 1. This is the thing. Return that node. So this is the get node function. In case of front insertion or in case of rear insertion, this function can be called to create one raw node with the value. Next, Assume that you have created the linked list. How to create the linked list we'll see later. This is the easiest part, so I'm taking this little early. Assume that linked list has got two nodes. I have to display the value. The end result which I am expecting is U1 NHAD 3 and 1 to 3, U2 Raj TS 3 3 4 5. That's all. There are two nodes has to be displayed in the need format. I'll be making use of display function as we are not modifying anything, so no need to return any value. So void. We have to pass the starting address of that linked list. I'll be taking that reference variable as p. Let it be this first node p. You can proceed only if p is not null. In this case, p is not null, so you do print operation. If p is null, that indicates that null linked list, nothing is there, so no need to proceed. So this is for that purpose. If p is not null, display the data in any format with the label. This is for the label. USN name, branch, semester, phone number, all the labels. We can have a number of nodes. Has to be repeated some number of times. You can repeat that till you don't have any more nodes. Assume that this is the first node. P is it null? P is not null because it has some data. P is not null, then you repeat it. What repeat? Now use printf statement to print the value, that is USN, name, branch, semester, phone number. P of USN, this should be obtained, that is U1. P of name, NH displayed. P of branch, AD is displayed. P of sem, 3 is displayed. P of phone number, 123 is displayed. Having done this, you go to the next node, that is P equal to P of next. After printing this, that P should be here, it should be pointed here. Now P should come here. P is P of next. Earlier P is here. P of next is here. That is our new variable P. P is equal to P of next. This is to move that pointer to the next node. Repeat that one. Once that is done, count the number of nodes. Already we have got the count variable that holds the number of nodes. In this case, you will be getting two. Number of nodes in this linked list is 2. So you completed get node and display function. If nothing is there, you say no data available and close the program. Now we will be seeing two major operations, insertion and deletion. Insertion can be done in the front end and rear end. Deletion can also be done at rear end and front end. First we will take insertion at front end. Assume that this is the linked list. This is a linked list. The front end is this one. When you insert here, this is called rear end. When you insert here, it is a rear end. When you insert it here, it is a front end. The function name is insert front and the starting address of the head is required. This head can be null, means that nothing is there. In this case, it is pointing to the first node. Okay. We need one variable to hold the raw node, that is new node. Okay. It can be done only if the number of nodes in the linked list is not more than or equal to max. Hardly it can permit us to have 4 nodes as we have declared earlier. If already reached number of nodes, already 4 nodes are there, we are trying to add one more. Already count value is 4, max 4, so you can say that it is a overflow. Otherwise, get one new node. In this case, this new node is obtained. We have got the function get node. You call that one, that returns that node. You hold it in new node. Suppose nothing is there. Nothing is there. Assume that this part is not there. That means head is null. What to do? That new node will become head node. Only one node that is recently added. No earlier node. That newly created node now becomes head. Otherwise, like the situation given here, it is not the null linked list. Head is there. So what to do? You have to bring this head to this one. Here upwards, new node is the head. For that purpose, new node of next equal to head. So one link you have to create it now. Like this. This is the thing. Having done this, earlier head was here. You have to bring that head to here. This is the thing. Return it. Return the head. This is how insertion at front is done. If head is null, that newly created node becomes the head node. If head is not null, that first new node has to point to the head node. Head you have to bring it. You have to set to that new node. Now insertion to the rear end. Assume that this is a linked list. Rear end is this one. When you add new node at the end, it is called rear end. Insertion rear one. The starting point of head is required. New node creation is required. If already reached the max number of nodes that you have set, that is 4 or 5 or anything, max, say overflow, otherwise you repeat it. Get the node till here it is same. If head is null, new node becomes head, otherwise what? Now you have to take one variable p because head is here, head will not change. P now should bring it to the last node in the linked list. For that you start with the p equal to head like this. Then is P of next is null. P is this one. P of next is not null. What to do? You move P from here to here. You have to move P equal to P of next. Repeat it. What about P of next? P of next is null. So you stop this process. Once this P is reached to the last, now what to do? P of next, P of next is equal to new node. That's all. P of next equal to new node. Return that node. Return that node. So you created linked list by inserting new node at the end, rear end. Front insertion and rear insertion over. Now we'll go for deletion. Suppose this is a linked list. Suppose this is a linked list. Now we have to remove this node and the head was here. After removing that head should jump by one place. As usual, delete underscore front p equal to head. Let p equal to head. If head is equal to null, that means nothing is there to remove, so overflow. Otherwise, head equal to head of next. As we are removing this node, head has to jump by one place. Head now it is pointing to this node H, the second node. So this statement will move that head to the next node. Free the old node. Already we have stored old head in P. P is now removed. The memory has to be utilized properly. Then, as we have removed that node, one node is removed, count should be decremented by 1, count minus minus. Return that, return head, because the list is updated after the deletion, so that head node has to be returned. Suppose head is null, nothing is there to delete, it is underflow. If head is not null, then you have to move that head to the next place, and using free you have to remove the current node to be deleted. Now delete from the array. If this is a linked list, I drawn that in the vertical format. This is the first node. First node is having the address of the second node. Second node is having the address of the third node. Third node is the end. So it is storing null value. In this case, this has to be removed. This is the purpose. This is the intention. Delete array node star head. P equal to head. If head is null, nothing is there to remove. That is underflow. Otherwise, what to do? Head of right now head is here. Right now head is here. Head of next is it null? If equal to null only. If not null, what to do? Head becomes null. If the first node itself only one node is there and head of itself is null, just remove it. Head becomes null. Otherwise, what to do? So you have to bring that p to this place. You have to bring that p to this place. P of next is not equal to null. P of next is not equal to null. What to do? So you assign this temporary with the variable q. P is now moving to here. Q equal to p. You take one more variable q. That variable holds that p value. Then p equal to p of next. P is moved now. This has to be repeated. Okay, we'll see what happens. P of next is it null? No. In the next case, This becomes q equal to p, and p equal to p of next. Now this becomes p. Okay. P of next, is it null? Yes, p of next is null. Comes out. Then what to do? Here already has got the address of p, you nullify it. P of next equal to null. So this is made null. Means this will be removed. Whatever the thing is there in p, you free it to efficiently use the memory, utilize the memory. As it is a delete operation, count has to be decremented by 1. So we have completed rear insertion, front insertion, rear deletion, front deletion. Coming to the main part. Initially, you declare some variables that are required. One is very important is the head node, initially set to null value. It is a student database. Initially, you ask how many students to create. Let n equal to that number of students. You repeat it, I equal to 0, I less than n, I plus plus. In the question, it is said that you have to use insertion at front method for creation. Just call the function, that's it. Then, these are the major operations that can be done as specified in the question. Display, insertion at front, deletion at front, insertion rear, deletion rear. Then push operation, stack on, stack pop operation, then exit. These you have to do. Okay, ask the choice. Choice, if it is 1, display. We have got the function display. Send the address of the head node. Suppose it is 2. It is insertion front, head equal to insert underscore front. That function can be, that has to be called. Break statement, because nothing, no other case has to be executed. Case 3, delete front, you call the function. Case 4, insertion rear, deletion rear. Corresponding function has to be called. Now stack push operation. Okay, I will indicate this is my stack. I will indicate that with the help of linked list. Now, if this is a linked list, 1, 2, 3. Number of nodes in the linked list is 3. This is the thing. Now, it is a push operation. That new element will come on to the top of that. Top is the rear side. So this rear insertion has to be called. This is for the push operation. For pop operation also same thing, only this node will go. That is again delete rear. Already functions you have got, you call it. That's all. This is how single linked list program works. Thank you.